So let's get started. Okay, so before we dive into the fun product and tech part of things, let's first define Meero and propershot so that we all know what we're talking about here. So Meero is the place that's going to make images more beautiful to essentially sell them better for different marketplaces. So we have 3 different products that specialize in 3 different marketplaces: the fashion marketplace, the cars marketplace, and the real estate marketplace. Today we're going to talk about propershot, and that's our product that's going to address the real estate marketplace. So what we're going to do is we're going to have a product that's going to have a bunch of different tools and features that real estates can use, such that once they took pictures of the properties they're trying to sell or rent, they can make those pictures look nicer, such that there's a higher chance of people actually wanting to even visit the property. So if you think about how you can change pictures in the context of propershot in real estate, there's 2 different but related things you can do. You could change the picture's colors, do things like adjust the exposure, apply white balance, even change the sky outside. And those are the things that propershot used to do exclusively prior to 2023. And while those kind of changes on the picture are going to help making this picture more attractive, it's not going to solve a problem when the content of the picture is problematic. Say you're trying to sell a home that has a very old style that's just not up to date with today's real estate interior design standards. Or say it's a very messy apartment, the client did not clean it up before, and you're trying to sell an apartment with a bunch of personal stuff in it. So what do? Basically, you're going to have to need editing features that are going to address the content part, not the quality part of the picture, but what's actually inside the picture. So that's what GenAI unlocked for us. It gave us new algorithms, very powerful algorithms, that could change the content of a picture of an apartment or of a house without changing the structure of the home, such that people who then view the pictures have a better chance projecting themselves into the property and contacting the real estate agent. So today, our 2 most powerful features are Magic Eraser and Home Staging, and they're both powered by GenAI, and those are the 2 features we're going to talk about today. I'll first start with Magic Eraser, and then Asya will tell us more about home staging. So Magic Eraser was first conceived with this idea that we would need a tool where when there's a picture with personal stuff in it or clutter in it, we wanted to have a tool that would remove that stuff in the picture. For example, say you have this picture of the bathroom, which looks fairly recently renovated, looks overall nice in terms of colors, but there are some personal stuff in there, in that left picture. There's a washcloth, there's what seems to be shampoo bottles, other things in the bathtub, and that's not great. Wouldn't it be nice if we just had a tool that's going to allow us to brush over those objects, and then they magically disappear in the picture as if they never existed? So that's what Magic Eraser is intended to do. When we first approached this problem, the computer vision team, we knew this was an in-painting problem. In-painting is not old in computer vision. It's a decade-old problem. What's new, though, is the GenAI features. So there's 2 big families of models today that address in-painting really well. There's GAN models, Generative Adversarial Networks, and there's diffusion-based models. So when we were handed this task of in-painting, we were kind of going back and forth between the 2 families of models. We were first very attracted to GANs because they have this nice one forward pass feature where, as opposed to diffusion models where you need multiple forward passes to get your final output. And since we wanted to have a real-time feature, we were attracted to those models. Also, we found that GANs worked pretty well when you were trying to remove small to medium-sized objects. They would not do so well, though, when you were trying to remove really large objects, especially compared with diffusion models, which had this really nice quality in terms of texture. But when we would sometimes take off-the-shelf diffusion models and try to remove an object, it would do that. It would remove an object, but it would also sometimes introduce a new one. And that's a frustration we were not ready to deal with. So to keep it safe for Magic Eraser V1, we went with a GAN-based implementation. We took the state-of-the-art GAN-based for in-painting for images, which is called Llama, not to be confused with the language model. This is just an in-painting model for images. We took that, we adapted it to our real estate images, we optimized it in terms of times, and we deployed it really fast. We put it in a archive format using PyTorch store serve, and then we put it in a Docker container, shipped it to the cloud, and then our web app and mobile app propershots could call the model endpoints. It was probably one of the fastest features we released, and we had incredibly positive feedback. It's kind of the feature that real estate agents didn't know they wanted until they had it, and now they can't live without it. However, what we feared might happen, happened. Real estate agents would sometimes select large objects in the image, say a rug on the floor, or a very large sofa, and the result was not looking good because of the GAN models. Let's take an example. If you have the picture on the left and you're trying to brush over, and here the mask is in yellow, you're trying to brush over small objects to remove them, the GAN's going to do really well with in painting. You're not going to see any artifacts. However, if you try to remove large amount of clutter, essentially removing a large context of the room, GANs struggle a lot with uncertainty. And that uncertainty is translated to a big, horrible blob that our real estate agents definitely cannot use. So what happens when you take a diffusion model? When you take a diffusion model, it's going to do so much better in terms of quality. However, it's going to do this behavior we already mentioned before. It's going to insert an additional object. And that's not something we want. This is a magic eraser. It's an object remover task. We want it to completely remove objects and not generate new ones. Looking at the quality, though, we knew that we had to go diffusion-based for Magic Eraser v2, but we had to solve this issue of generations. Oops. Uh-oh, no, that's way ahead. All right, oh no, it's just one slide. All right, we'll talk about this slide. Okay, so we did what computer vision engineers would do. We took an off-the-shelf diffusion model, SDXL in painting, and we fine-tuned it on our real estate data. Just, wondering, what's that gonna do? The answer is that it's gonna help in terms of a bit of the in painting quality. It's not gonna help in terms of this generation bias of wanting to actually introduce new objects in the image. So doing a simple LoRa fine-tuning is not going to just cut it for that. So we had to brainstorm a little bit, and we finally found the trick. So here's the trick. So first, let's take a step back. In our task, there are examples of good generations and wrong generation. A good generation would be where the user has selected a region. So here would be the white region on the left. We don't see the input image here on this slide. But where they have selected the white region, we do not want to see any object appear. We don't want that. We don't want the diffusion model to do that. A wrong generation would be where the user has selected a region again, in this white area. In the output image, there's an object that appeared. That's wrong. That's what we don't want. Okay. So what if during training, we not only feed examples of good generations, but also of wrong generations? And the rest is very important. When we show an example of wrong generation during training, we need to link it to a unique caption, a specific set of tokens that doesn't change, such that throughout training, the diffusion model learns to bind this wrong behavior with a specific caption. And so once that's done, once this behavior is learned through text in a way, you can then use it as negative prompt at inference, because it's learned to tokenize in a way this behavior, and then you can use it as a negative prompt. So you might wonder, okay, but how do we actually get this data set of wrong generations? Well, thankfully, Magic Eraser v1 usage is giving us that. We can make the assumption that our real estate agents have been selecting objects to remove for us. And so here we have examples of masks with objects at the region. And instead of using their input image, we use it as our output image as an example of wrong diffusion. So that's how we get the training data. We put a couple thousand examples of wrong generations in the training. And we always make sure to link it to this unique caption. And then we use this caption in the negative prompt at inference. And that does the trick. The middle picture is the one we already saw, where you take an off-the-shelf model and you do in painting, where it generates an object. And the right column is the Magic Eraser that's a result of training this SDXL in painting with this special unique identifier trick for wrong examples. Our real estate agents noticed the difference in quality and definitely picked up on it and used Magic Eraser even more than before. And throughout 2024, especially early 2024, we did more work on Magic Eraser. We introduced a third version, where the version focused more on the speed of Magic Eraser while keeping the quality of it. So we did LCM, which is distillation-based methods to speed things up but keeping the quality. And we got it down to 6 seconds, which we were pretty happy with. And with some additional infrastructure change in the model endpoint, we're now down to 4 seconds. So it's a fairly fast feature. And our real estate agents are pretty happy with the speed. They're pretty happy with the quality too. Almost 9 times out of 10, they save out the picture they get from Magic Eraser. That's it. I'll then leave the mic for Asya for home staging.
Hello, I'm Asya, and now I'll be talking about our second popular feature, home staging. So what is home staging? Well, Magic Eraser aims to depersonalize a space. Home staging aims to personalize a space in a way by either changing the style of existing furniture or introducing new furniture in a certain style that a client does like and allows them to really project themselves into the space. We also wanted to first release a feature very fast, like Magic Eraser, so that we have a product that worked. Our first iteration was a redecorate pipeline, which basically aimed to repurpose off-the-shelf diffusion models and aimed to change the styles of the existing furniture in a furnished room. At first, we tried a standard off-the-shelf image-to-image pipeline with Stable Diffusion 1.5. But as we can see, the room structure was not preserved. So we had to think, how can we preserve the room structure? So we used a very influential technique, maybe some of you know it, ControlNet, which guides the diffusion process with additional constraints. In this case, we use an in-painting mask and a segmentation mask. The in-painting mask basically means that no region in these walls can be changed by the generation, and the segmentation mask means that the generation will try to preserve the furniture the type of furniture that was in the first input image. With this, we can change the style with the prompt and have this nice, I think, bohemian stylized image in the end without compromising room structure. But of course, as the name suggests, redecorate means we do redecorate. The strong segmentation constraint that we used in ControlNet means that existing furniture will stay that way, and if there's no furniture in the image, then there will be no furniture in the output image, or very little, as we see here. So we had to develop a new pipeline to furnish empty rooms. So how do we go about this problem? Well, we wanted to train our own generative model. And when we train our own generative model, it means we need our own data. But what data do we need? In this case, we want image pairs. On the one hand, we want empty rooms. And on the other hand, we want the same exact room furnished so that the model can actually learn how to furnish this empty room. But of course, such data doesn't exist. And creating this type of data, real data with photographers, would be an extravagantly costly task, both in terms of time and money. So how did we do this? Well, we used our internal real estate internal data with furnished rooms. And what did we do? You guessed it, we used our good old Magic Eraser. We iteratively used it to remove all of the furniture and create these empty rooms. Then we segmented these empty rooms to have this sort of layout map. Now we have these image pairs that we can use to train our own generative model. On the one hand, a layout map, and on the other hand, the furnished rooms. We created about 20,000 layout furnished pairs to train our own model. With this, we fine-tuned the off-the-shelf segmentation ControlNet off layout data. So once this layout ControlNet was trained, we can use this trained model to generate a furnished room with a room that looks different than the input image, but has a very similar layout. But of course, it's not the same image. So we had to find a way to furnish this input image too. First, we copied and pasted all of the furniture from the generated image into the input image. And then we used techniques like stylization, integration, upscaling, and refinement. Techniques very similar, which we used in the V1 version of home staging to produce our final result. And this would be a type of result which we achieved for, I think this is modern style or Scandinavian style for the input image. On top of being able to furnish empty rooms, we also wanted to improve quality. To do this, we wanted to build our own real estate foundation model. For this, we used our internal real estate data, which we have plenty of. We augmented it into styles that the client might want, like modern style, bohemian style, etc. And we used these augmented data to fine-tune Stable Diffusion 1.5. This way, this foundation model would know better how to create furniture and rooms of proportionate sizes. The whole home staging V2 pipeline contains several components. Of course, we use our real estate foundation model, and on top of that, we insert the layout control net, which I just talked about. We also fine-tuned our own in-pane control net on our internal data, and we use the off-the-shelf segmentation control net as we did in home staging V1. So, looking ahead, what's next for propershot in terms of Gen AI? So, first of all, the numbers speak for themselves. For these two very popular features which we just introduced, converted users used Magic Eraser 4.43 times more often than users who did not convert. Converted users used home staging 2.15 times more than non-converted users, which implies that these Gen AI features had a very strong impact in converting users. So users clearly wanted more Gen AI, and we gave it to them. So since our first release of our Gen AI features in November 2003 of Magic Eraser V2 and home staging, on top of iterating through subsequent versions of them, we introduced 3 new Gen AI features. In July, we introduced wall painting. In October, just now, we introduced automatic listing generation. And just now in November, we released floor replacement, which I'll show now. Uh-oh. Well, unfortunately, you can't see the beautiful wall painting results, but they're stunning. So you just have to take my word for it. Okay, but the replaced floor you can see. So in this case, we have an input image, and the output image would automatically replace the floor into several floor choices like hardwood floor, several choices of tiles, even this, I don't know, yeah, even those type of tiles, and carpet as well as concrete. So the results look very natural without compromising room structure as they did for wall painting. These 2 features, floor replacement and wall painting, are for users who want to do minimal renovation strategies on their homes without sometimes the over-the-top ideas that home staging provides. These Gen AI editing features are naturally complementary with each other. In this example, home staging was applied, followed by wall painting, then floor replacement, and then Magic Eraser. Our users love to apply them subsequently on top of each other, and it produces great results. We're also very proud to have released our first text-based Gen AI feature just recently in October. So this automatic listing description takes in all of the images in a given listing as well as some text-given inputs such as the address and surface area of the property, and describes the home in a very professional manner, as well as giving some practical information in relation to the address, such as transportation and tourist attractions. So that's it for us now. Thank you very much for your attention, and we're very happy to take any questions.
Allô, allô. Donc on va prendre des questions. Est-ce que si vous en avez, vous levez la main et puis on va passer les micros. Hop, shotgun, bien joué.
Bonjour. À un moment dans le talk, vous avez parlé d'améliorer les performances en temps d'inférence pour Magic Eraser, par exemple. Est-ce que c'est possible d'en savoir plus?
Comment on a fait pour réduire le temps d'inférence? On a fait plusieurs techniques. Le changement le plus notable, c'était l'entraînement de notre propre LCM. Donc, c'est un modèle teacher-student model qui apprend au modèle en gros, au lieu de faire, je ne sais pas, 15 itérations, parce que si vous connaissez les modèles de diffusion, vous savez que c'est long, ça prend peut-être parfois 20 itérations, 30 itérations pour avoir une image de bonne qualité. Un LCM permet de réduire ces itérations jusqu'à peut-être 4. Nous, je pense finalement, on est à 4 ou 5 itérations à la fin. Donc ça, c'était le changement le plus notable. Et on a eu d'autres petits changements. On a fait une compilation de notre modèle qui a gagné du temps, et aussi quelques petits changements vis-à-vis de nos algorithmes post-processing, on peut dire. Et ça a aidé aussi.
Bonjour.
Bonjour.
J'avais une question sur la première partie où vous en fait retirez des choses de la pièce. Moi, je me demandais, il peut forcément y avoir entre guillemets, des erreurs. C'est-à-dire que le système va supposer ce qu'il y a derrière l'objet par rapport à ce qu'il y a autour, et il va recalculer. Est-ce que, il peut y avoir des risques d'erreurs qui peuvent être gênants? C'est-à-dire qu'en fait, derrière cette armoire, par exemple, il y avait un mur qui était complètement abîmé et on ne le voit pas sur la photo. 2, lié à ça, un risque d'abus peut-être des agents. Et du coup, comment on gère en fait, on essaye de cacher des choses qui ne vont pas dans l'appart pour générer du lead. Et 3, le devoir d'information vis-à-vis des utilisateurs, enfin des potentiels acquéreurs, en fait, cette image a été modifiée avec l'IA, par exemple.
Oui, dans le cas de... Si on enlève une armoire, par exemple, avec quelque chose qui n'allait pas derrière et qu'on ne voit pas, ça c'est... en fait, que ce soit les GAN ou les modèles de diffusion, ils vont utiliser le contexte qu'il y a autour de cette armoire, donc ils ne peuvent pas, c'est ça, voir s'il n'y avait pas d'indice autour à la base. Les agents immobiliers sont en fait responsables de leurs actions, mais on a bien un petit texte sur l'image générée qui dit que cette image a été modifiée par l'IA. Quand ils publient sur leur site en question, c'est écrit dessus.
Merci pour la présentation. Juste pour prendre l'axe d'amélioration de la qualité de photo, comme le sujet il est très subjectif, comment vous avez fait pour l'évaluation des performances des modèles?
Donc pour la partie... Ah oui, ça c'est une bonne question.
Disons, au début, on a, en tout cas, je peux répondre pour Magic Eraser, on a utilisé des métriques connues dans le monde de in-painting et la qualité d'image, c'est-à-dire le FID score et aussi le LPIPS. Ces métriques étaient un peu difficiles à vraiment interpréter parce que ces métriques ne sont pas parfaites, je ne sais pas, mais... on s'est basé sur ça pour faire beaucoup de nos choix architecturaux. Et après, on a utilisé nous-mêmes, les humains, pour évaluer la suite. Donc voilà, c'était moitié-moitié. Voilà.
Merci.
Une dernière question.
Oui, bonjour, merci pour cette présentation. J'avais juste une question à savoir si c'était S'il y avait un impact sur les ventes de maisons derrière, si vous avez ce genre de chiffres.
Un impact sur les ventes, c'est ça que...
Ouais, des maisons et des appartements dans le secteur de l'immobilier.
Donc nous, on n'a pas les données sur... on ne sait pas. Ce qu'on sait, c'est bon, c'est lié, mais les agents ont besoin du produit et disent que eux, ça leur est très utile. Après, nous, on ne sait pas si down the line, ils arrivent à vendre plus, mais s'ils l'utilisent et qu'ils payent pour ce produit, j'imagine que c'est parce que... j'espère qu'il y a des ventes qui arrivent en plus.
Merci beaucoup. Il y a les pauses pour continuer à poser des questions si vous en avez encore. Et je laisse la main à Anne-Claire.
Merci beaucoup. On leur fait un tonnerre d'applaudissements. Merci beaucoup, c'est vraiment bluffant et merci d'avoir partagé votre cheminement. Où est-ce que vous avez fine-tuné? Comment est-ce que vous avez pris vos différents choix et orientations? On va maintenant